Good day everyone. So in this video, you're going to learn about solving linear inequalities. First, let us define linear inequalities. These are solved by a method similar to solving linear equations. The difference between linear equations and inequalities are the sign used in solving for the solution set, applying the multiplication property and graphing. Let us review the two inequality symbols, less than and greater than, in the chart below. So we have here inequality symbol, less than and greater than. Okay, first we have A is less than B, meaning A is to the left of B on the number line. Okay, so for example, this is our number line. Okay, so according to this, A is on the left of B. So A is on the left of B, meaning A is less than B. All numbers going to the left side is smaller than the numbers going to the right side. Next, we have C is greater than D, meaning C is to the right of D on the number line. Okay, first we're going to draw a number line and then we're going to put our variables. So we have C on the right of D on the number line. So C is on the right, meaning C is greater than D. Okay, so an inequality differs from an equation only with respect to the comparison symbol between the two quantities being compared. In place of the equal sign, we use less than or equal to, greater than or equal to. So to solve an inequality means to find its solution set. For example, to solve the inequality x less than negative 2, we must find all the real numbers that will make the inequality true. Okay, some real numbers make x less than negative 2 is a true statement, and some real numbers make x less than negative 2 a false statement. Okay, so let us find out what are the solutions of x less than negative 2. Okay, so what are the numbers smaller than negative 2? Okay, if we have negative 3, so negative 3 is our x. Negative 3 less than negative 2. Okay, check. If we have negative 4.5, negative 4.5 less than negative 2 is also checked. If we have negative 100 less than negative 2, that is also checked. And according to the definition, not all real numbers make x less than negative 2 a true statement. So for example, if our x is negative 1, so negative 1 less than negative 2, okay, that is wrong or false. 0 less than negative 2, false. If you have 3 less than negative 2, that is also false. Okay, so it is not possible to list all the solutions of x less than negative 2. However, a number line can be used to graph the solution set. Okay, so this time we're going to graph x less than negative 2 to find out what are the solutions of this inequality. So x less than negative 2. Okay, so x less than negative 2. Okay, so we're going to draw our graph. Negative 2, so it is here, negative 2. And then what are the numbers that are smaller than negative 2? So those are the numbers going to the left. Okay, those are the numbers that going to the left. Okay, so we draw open circle, meaning negative 2 is not included in our solution set. Because negative 2 less than negative 2 is false. Okay, so we have the solutions negative 3, negative 4, negative 5, negative 6, and all the numbers going to the left. And to write our interval notation, we have negative 2, okay, and then going to the negative infinity. Right? So we use parentheses, meaning negative 2 is not included in our solution set. Addition and subtraction property of inequalities. For all real numbers a, b, and c, if a less than b, then a plus c less than b plus c. That is adding the same number to each side of the inequality. Will not change the solution set. Okay, solve the inequality x plus 5 less than 7. Okay, first we're going to write our inequality. So x plus 5 less than 7. So we're going to take away 5 on this side of our inequality. Okay, so we're going to get the additive inverse of 5, that is negative 5. So if we subtract negative 5 on one side, therefore we're going also to subtract 5 on the other side. Okay, so x, this is 0 or cancelled, less than 7 minus 5 is 2. Okay, so our solution is x less than 2. Those are the numbers that are smaller than 2. Okay, x less than 2. Okay, next solve for x in x minus 6 less than or equal to negative 3. Okay, so x minus 6 less than or equal to negative 3. Okay, so x minus 6, we're going to take the additive inverse of negative 6. So plus 6. Plus 6 on both sides. Okay, x, this is 0, less than or equal to negative 3 plus 6, go to subtraction, and 6 minus 3 is 3. Positive is our bigger number, so positive 3. Therefore, x less than or equal to 3. So those are the numbers that our solution are the set of numbers that are less than or equal to 3. So we have 3, 2, 1, 0, and all of the negative numbers. Okay, multiplication property of inequalities. So if a, b, and c are real numbers, letter A, and c is greater than 0 or c is positive, then a greater than b and ac greater than bc. A less than b and ac less than bc are equivalent inequalities. Next, c is less than 0 or c is negative, then A greater than B and AC less than BC. A less than B and AC greater than BC are equivalent inequalities. Okay, let us solve for x or for a in 3a less than or equal to 18 and graph the solution. Okay, look class, we have here the negative sign on our variable. Okay, so negative 3a less than or equal to 18. So if we have negative sign on our variable, the inequality symbol will change. So from less than going to greater than. Okay? Eliminate negative 3 from A. So we're going to divide both sides by negative 3. Negative 3. Because negative 3 divided by negative 3 is 1. 1A or just A. And then from less than, we'll have greater than or equal to. So 18 divided by negative 3 is negative 6. Therefore, our solution is A greater than or equal to negative 6. A greater than or equal to negative 6. And then if we want to graph our solution, so we have negative 6. Okay, so it is here, negative 6. Negative 6. And then A is greater than or equal to negative 6. So we need to color our circle. So that is closed circle, meaning negative 6 is also included in our solution set. So A is greater than or equal to negative 6. So from negative 6 going to the right side of our number 9. So we have the solutions: negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and all of the positive numbers. And then if we want to write that on our or in interval form, we have negative 6. We're going to use bracket because negative 6 is included in our solution set. And then from negative 6 going to positive infinity. Okay? Next, solve negative x over 4 greater than 2 and graph the solution. So again, we have negative sign on our x. Okay, so negative x over 4 greater than 2. Okay, so we know that there is one here. So if we're going to get the reciprocal of negative 1/4, that is negative 4 over 1 or negative 4. Okay, so we're going to multiply both sides by negative 4. Because negative 4 times negative 1/4 is 1 or just x. And then from greater than going to less than, because we have negative sign on our variable x. Next, 2 times negative 4 is negative 8. Okay, so our solution, x less than negative 8. Okay, x less than negative 8. Okay, let us graph our solution set. Okay, negative 6. Okay, let us extend this first, our number line. So we have negative 7, negative 8, negative 9, then negative 10, and so on. Okay, so negative 8. it is here. So we're going to use open circle because negative 8 is not included in our solution. X less than negative 8. Numbers that are smaller than negative 8. So those are numbers going to the left from negative 9, negative 10, and so on. Okay, so in interval form, it will be from negative 8 or from negative 9 because negative 8 is not included, going to negative infinity. Next, solve and graph 2 times the group 1 minus 3x plus 4 less than 4x minus 14. Okay, so to eliminate our grouping symbol or the parentheses, we're going to use the distributive property of multiplication. 2 times 1, that is 2. 2 times negative 3x is negative 6x. Okay, and then copy 4 less than 4x minus 14. Okay, so our goal is to separate variables from the numbers. So on the left side will be our variables and on the right side will be our numbers. Okay, so first let us combine these two. 2 plus 4. Okay, so we have negative 6x and then 2 plus 4 is 6 plus 6 less than 4x minus 14. Okay, next. We're going to eliminate 6 here. So we're going to subtract 6 on both sides. So minus 6x plus 6 minus 6 less than 4x minus 14 minus 6. Okay, so negative 6x 0 less than 4x. Negative 14 minus 6 is negative 20. Okay, next, eliminate 4x from this side. So we're going to subtract 4x on both sides. Okay, minus 4x less than 4x minus 4x to make it 0 minus 20. Okay, negative 6 minus 4 is negative 10. Negative 10x less than, this is 0 and negative 20. Okay, so according to the rule that if we have negative on our variable, we're going to change the inequality symbol. So from less than going to greater than. And then if we want to eliminate negative 10 from x, so we're going to divide both sides by negative 10. Negative 10. So we have x greater than positive 2. X greater than positive 2. Okay, let us graph x greater than 2. Okay, so we have positive 2, open circle, and then what are the values of x that will satisfy this inequality? So x greater than 2, meaning those numbers that are bigger than 2. So we will going to draw our line going to the right. We have 3, 4, 5, 6 as the solution and so on. Okay, so in interval form, it will be parentheses 2 going to positive infinity. Close parentheses. And that is all about solving linear inequalities. So I hope you learned from this video and see you next time.